Every week, 3,000 people lose a limb, and there are 50,000 new amputees every year in the United States alone, 75% of which having a hand or arm amputation. Yet, many amputees can't afford functional prosthetics due to the average prosthetic cost of $18,000.
With our hand design, more people in need of a prosthetic will have access to an inexpensive and affordable model like our own, without having to sacrifice on practical aspects or functionality.
After a week of researching the models that currently exist and what project would be feasible to undertake in our allotted time with our resources, we decided to combine the Kwawu 2.0 hand design with a retooled arm design from InMove. To build the arm, the downloaded STL files had to be measured, edited, and sliced with the softwares Tracker, Tinkercad, and Cura respectively. Furthermore, to make the hand appear more lifelike, all electronic components of the hand are encased in the palm, wrist, and arm. The G-codes for both the hand and arm were downloaded from Thingiverse and then were uploaded to our own personal printers, the Ultimaker 2 Plus and the Ultimaker 3. Each printer uses a PLA filament to print the main structure and a Filaflex filament to print the joint actuators. Because Filaflex filament is quite finicky, a level of trial and error was necessary before a successful print occurred. We kept part of the electrical component and stringing hidden inside the arm for both aesthetic reasons and to ensure no outside forces impede with the tension of the strings.
In addition, our design is unique in the sense that it provides better dexterity, allowing individual fingers to move separately from one another instead of all at once, like many current models. The arm works by mapping the motion of the opposite hand and mimicking it in the prosthesis. When the real functioning hand moves, the flex sensors mounted on a glove receive the signals of motion and then turn the impulses into electronic data. This model is still very much so a prototype. It is fully functional in the way we intended. However, our initial idea was to make a myoelectronic prosthesis. A myoelectronic prosthetic is controlled by a myoelectronic bridge sensor which can detect muscle impulses to control the servo's motors. However, we are still very proud of our current model and its functionality.